Hello everyone. In this first video, we're going to be discussing the basic rules of differentiation from your note packet. And so we're going to be starting with rule number one, basic rule number one on page 14 of your note packet. Okay. The first rule, rule number one, is the derivative of a constant. And just to remind you, what the derivative of a function does for us is it tells us the slope of the curve for each value of x. We know that the slope of a straight line is the same at every point on the line, but for a curve it's constantly changing. And so the derivative tells us the slope of the curve for each value of x. So for our first rule, the derivative of a constant, if our function f of x is equal to c, a constant, then the derivative of f of x, denoted f prime of x, is just equal to 0. And that makes sense. So the derivative of a constant is equal to 0. That makes sense because if I replace f of x up here with the variable y, I have the equation y equals c. And the equation y equals c is just the equation of a horizontal line. And we know that the slope of a horizontal line is 0, right? Horizontal line is perfectly flat. It's not tilted upwards. It's not tilted downwards. The slope is 0, So this makes sense, right? It goes with our intuition. So in your packet on page 14, the first example, right? If our function f of x is equal to 10, then the derivative of f of x, denoted f prime of x, is just equal to 0. And so that's true for any constant. Rule number two, basic rule number two, is called the power rule. And the power rule says if my function f of x is equal to x to the nth power, where the number n in the exponent is any real number, then the derivative of f of x, denoted f prime of x, is equal to n times x to the n minus 1 power. To find the derivative f of x, x to the nth, we just bring the exponent n down in front of the x and subtract 1 from the exponent. So as an example, if I have f of x is equal to x squared, then the derivative of f of x, which we denote with f prime of x, is equal to 2x. I bring the 2 down in front of the x, and I subtract 1 from the exponent. So f prime of x tells us how steep the curve of x squared is for each value of x. So this is the answer. In the second example, we have g of x is equal to x to the 99th power. So the derivative of g of x, which we denote with g prime of x, is equal to 99 times x to the 98th power. We bring the exponent 99 down in front of the x, and then we subtract 1 from the exponent. And so g prime of x is equal to 99 times x to the 98th power. So that's the power rule. Rule number 3 has to deal when you multiply a function by a constant. So I'm on page 15 of your packet. The derivative of a constant multiple of a function. So example 1, so if I have the function g of x, which is equal to the constant c times the function f of x. Okay. C is a constant, just some real number off the real number line. Okay. Then the derivative of g of x, which we denote with g prime of x, is equal to the constant c times the derivative of f of x, which we denote with f prime of x. So g prime of x is equal to c times f prime of x. So in calculating the derivative, we just carry this constant multiple c along. Okay? So in our first example, in example 1 in your packet, we have y is equal to 3 times x to the 4th. You're given that's the function. Y is equal to 3 times x to the 4th. Well, this 3 is just a constant multiple, so we just carry it along in calculating the derivative on the right-hand side. So since on the left-hand side we have y, we denote the derivative on the left-hand side with y prime. That's not a 1 in the exponent, that's a prime, right? So it's pronounced y prime on the left. So in calculating the derivative on the right-hand side, we just bring along that 3, that constant multiple 3, and then we multiply it by the derivative of x to the 4th using the power rule. Then the derivative of x to the 4th by the power rule, you bring the 4 down front, subtract 1 from the exponent. You have 4 times x cubed. 3 times 4 is 12. So y prime is equal to 12 times x cubed. And that's the derivative of y equals 3 times x to the 4th. The 4th rule of our basic derivatives is called the sum and difference rule. And the sum and difference rule basically says if we have a function with multiple terms in it, we can differentiate it term by term. So rule 4, called the sum and difference rule. I'm on page 16 of our packet. Says if I have the function h of x, which is the sum or difference of the two functions f of x and g of x, then the derivative of h of x, which we denote with h prime of x, is equal to the derivative of f of x, which is f prime of x, and then plus or minus, depending on whether we're adding or subtracting, the derivative of g of x, which we denote with g prime of x. So this says that we can differentiate term by term of a function with multiple terms. So as an example from your packet, we have y is equal to 3 times the square root of x plus 2 over x cubed. Well, you know that before we can differentiate, okay, we have to rewrite this on the right-hand side so we can use basic rules of differentiation, rules 2 and 3, okay? So, square root of x is the same as x raised to the 1/2 power. And 2 over x cubed is the same as 2 times x to the minus 3 power, right? The minus sign in the exponent means reciprocal. So x to the minus 3 is the same as 1 over x cubed. Okay? And both those we're multiplying by 2. Okay? So the derivative of y, which we denote with y prime, we can differentiate term by term, right? We have 2 terms in our function. 3x to the 1/2 is one term, and 2 times x to the minus 3 is the second term. So in the first, differentiate the first term, we carry the 3 along, and we differentiate x to the 1/2 using the power rule. Bring the 1/2 down front, subtract 1 from the exponent. When we do that, we have 3 times 1/2 times x to the minus 1/2. Now when we differentiate the second term, we carry the 2 along. And then when we differentiate x to the minus 3, we bring the minus 3 down front of the x and subtract 1 from the exponent. Minus 3 minus 1 is negative 4. And then if we can clean this up a little bit, y prime, right, is equal to, this first term, 3 times 1/2 is 3/2. And in the second term, 2 times minus 3 is minus 6. So we have minus 6 times x to the minus 4th power. And that's the derivative, okay, of our function y equals 3 times the square root of x plus 2 over x cubed after we clean it up a little bit. And you don't have to simplify, right? You can leave those exponents as negatives, okay? All right, so that wraps it up for the first 4 basic rules of differentiation.